Hi, my name is Matviienko from Technical University of Darmstadt, Germany. I'm going to present our work titled VRtangibles, assisting children in creating virtual scenes using tangible objects and touch input. This work was conducted together with my colleagues Marcel, Florian Müller, Martin Schmitz and Max Mühlhäuser. The process of creating virtual worlds requires a technical background, which restricts the user group of active virtual world creators primarily to software developers. The issues of a technical barrier are particularly challenging for children, who are usually exposed to virtual reality as passive users and miss an opportunity to become active creators. Although there has been a big body of work done to facilitate children's entry point into technology using physical computing toolkits, tangible and visual programming environments, and variable computing platforms, there has been little to support children's active participation in creating virtual reality scenes. A good example of physical manipulation in a virtual environment includes virtual bricks. It is a Lego-based toolkit that facilitates physical manipulation in VR by offering a set of feature bricks which emulate and extend the capabilities of default controllers. Using this toolkit, users can build a proxy of a virtual object using Lego bricks and operate a virtual object using its proxy. In another toolkit called Andrii, Fake et al. Added more flexibility to the interaction with tangible objects by introducing stretching and bending of 3D printed objects, in addition to translation and rotation. In this work, we aim to provide an intermediary step towards familiarization with VR as active creators, by allowing non-tech-savvy users, for example children, to create virtual scenes playfully without writing a code and instead focus on creative expression. To facilitate the fun and quick creation of virtual scenes, we develop a virtual environment where children can create virtual scenes while being inside the virtual world. From the interaction perspective, we have employed two interaction techniques to facilitate direct manipulation of virtual objects known to children from daily interaction. The first one is tangible input from playing with toys, and the second one, touch input, from playing with smartphones. We combine the virtual space and the interaction techniques in the system called VRtangibles, which includes a tablet, a set of tangible objects, and the virtual reality environment shown in the headset. Children can create virtual scenes by placing tangible objects on the tablet while wearing VR glasses, and the virtual objects will instantaneously appear in the virtual world. In this video, we can see a person who can locate a tangible object in the real world and place it on the tablet. The object instantaneously appears in the virtual world and can be further modified using the touch input. The virtual world can be scaled and type of the color of the objects can be changed. Another objects can be placed on the scene and its properties are modified using soft buttons. For dynamic objects, in this case it is a car, a user can specify a trajectory using a touch input when the finger is released and a virtual car follows the trajectory. To evaluate the effectiveness of the proposed system in facilitating children's familiarization with virtual reality via hands-on activities, we collected preliminary findings from a user test with 6 children. We evaluated VRtangibles in a lab experiment and compared it to the state-of-the-art tool called CoSpaces. For the first task, which was a static setting, children had to create a virtual scene with 2 houses, 2 trees and 1 car. For the second task, dynamic setting, children had to create a virtual scene with 3 houses placed in the middle, 2 forests with 3 trees each to the left and right sides from the houses, and 2 cars in the front and behind the houses. After placing the car, children had to assign driving trajectories to it to bring them to movement. As a result, we found out the children were on average quicker in creating virtual objects with mouse and keyboard. They had also way more fun interacting with VRtangibles compared to keyboard and mouse. And moreover, children tend to use tangible objects more often when they solve a predefined task. So to sum it up, we can say that we see our work as a basis for familiarization with VR environment and an approach to include non-tech-savvy users in the active creation of virtual scenes. We aim to further extend the idea of the proposed system by integrating tracking of children's hands using off-the-shelf VR gloves and enable the creation of virtual models by scanning children's own toys to facilitate personalized interaction. That was VRtangibles. Thank you for your attention.